In this video, we're going to talk about lesson 3.7, which is factorization. This lesson is found on page 92 in the textbook. So the first method of factorization is taking out a common factor. So in this first problem, we'll look at taking out a monomial factor, and the next two problems we'll look at taking out a binomial factor. So what you do in taking out a common factor is you find the largest common factor of two or more terms that are in a polynomial, and then you can divide each of those terms by that one common term. So for example, in this example, 4x squared y plus 8xy, the largest common factor is largest common constant is 4, largest common power of x is x, and the largest common power of y is equal to y. Then when you divide 4x squared y over 4xy, you get, then the 4's cancel, the y's cancel, and then this just becomes x. So you get x. So that this is equal to x. Then you get 8xy over 4xy, which is equal to these x's cancel, the y's cancel, and this just becomes 2. So this is equal to 4xy times x plus 2. Now you can do the same thing with a binomial factor. So in this example here, we have 2xy plus times x minus y plus 4y times x minus y. So if you take out a x minus y from both terms, you get x minus y times, if you divide 2x plus 5 times x minus y divided by x minus y, you can cancel out the x's minus y's and you get 2x plus 5. And if you do the same thing for the next term, which is 4y times x minus y, and you divide x minus y, you can cancel these and you get 4y. So that means that this is equal to 2x, or x minus y, times 2x plus 5 plus 4y. Finally, here you can see that you can factor out a p minus 2, but over here it's 2 minus p. So you have to first factor out a negative 1 from this side. So this becomes 3n times p minus 2 minus 4 times p minus 2, since you take out a negative 1 from this side and then put it over here. So then now you can take out a p minus 2 from both sides. So this becomes 3n. So this be p minus 2 times 3n times p minus 2 over p minus 2 minus 4 times p minus 2 over p minus 2, which is equal to p minus 2 times 3n minus 4. The next factoring method is factoring by grouping. In this factoring method, you take out a common factor from two different groups of terms, and then you can factor them out and take out a common factor. So first problem is factorize x squared plus yz plus xy plus xz. So in this case, we will take x squared and xy as one group, and then yz and xz as another. So this becomes x squared plus xy plus yz plus xz. So then you can take out a common factor of x from this side, and you can take out a common factor of z from these two terms. So this becomes x times x plus y plus z times x plus y. Then you can take out a common factor of x plus y from both of these two terms. So this would become x plus y times x plus z. The next factoring technique is to factor using identities. So first example is factorize x squared plus 8x plus 16. So this is an example of the x plus a identity, x plus a squared identity, which is equal to x squared plus 2ax plus a squared. So in this case, a squared equals 16, and 2a equals 8, which means that a equals 4. So this is equal to x plus 4 squared. The next problem with using identities is factorize 49x squared minus 84xy plus 36y squared. So to do this, you notice that 49x squared is equal to 7x squared, and 36y squared is equal to 6y squared. So this means, and negative 84xy is equal to negative of 2 times 7x times 6y, which means that if 7x equals a and 6y equals b, this can be written as a squared minus 2ab plus b squared, which is also factorable as a minus b squared. Therefore, this can be factored as 7x minus 6y, the whole thing squared. The final problem we'll be looking at using identities is to factor 49x squared minus 64y squared. So to do this, you notice that 49x squared equals 7x squared, and 64y squared equals 8y squared. Therefore, this is an example of the a squared minus b squared identity, which is equal to a plus b times a minus b. Therefore, 49x squared minus 64y squared is equal to 7x plus 8y times 7x minus 8y. The last quadratic factoring technique we'll be looking at is factoring ax squared plus bx plus c. So first example is x squared plus 8x plus 15. So remember that the binomial expansion of x plus a times x plus b is equal to x squared plus a plus b times x plus ab. This means that in this case we're looking for a and b such that a plus b equals 8 and ab equals 15. So that means that a equals 3 and b equals 5, or you can do a equals 5 and b equals 3. So that means that this is equal to x plus 3 times x plus 5. The next problem is to factorize 7c squared plus 2c minus 5. So this can be written as 7c plus a times c plus a, or c plus b. And when you expand this, you get 7c squared plus ca plus 7bc plus ab is equal to 7c squared plus a plus 7b times c plus ab. That means that a plus 7b is equal to 2 and ab equals negative 5. So that means that b is equal to 1 and a is equal to negative 5. So that means that this can be factored as 7c minus 5 times c plus 1. Next, we will be looking at factoring using cubic identities. So the first problem is x cubed plus 15x squared plus 75x plus 125. So the first thing to notice is that x squared is equal to x cubed is equal to x cubed, and 125 is equal to 5 cubed. Then you can notice that 15 is equal to 15x squared is equal to 3 times x squared times 5, and 75 is equal to 3 times 5 times x, 3 times 5 squared times x. And this is an example of the a plus b cubed identity, which is equal to a cubed plus 3a squared b plus 3ab squared plus b cubed. Therefore, this is equal to x plus 5 cubed. The next problem is to factorize 8p cubed minus 12p squared q plus 6pq squared minus q cubed. So again, 8p cubed is equal to 2p, the whole thing cubed, and this is still equal to q cubed. Then 12p squared q is equal to 3 times 2p squared times q. And this 6p squared q is equal to 3 times 2p times q, which means it's an example of the a minus b cubed identity. It's equal to a cubed minus 3a squared b plus 3ab squared plus b cubed, which means that this is equal to 2p minus q, the whole thing cubed. That is the end of the video.